It is my pleasure to welcome Mr. C.A. Prasad, the President of the Pre-Engineer Society of India. He holds 41 years of experience in precast structures as founder of Metey Engineering and Consultancy Service Private Limited. Mr. Prasad aids developers in establishing precast factories and consultants on prefab structures in India. He is also a Board of Studies member in South Indian Engineering Colleges. Today, Mr. C.A. Prasad will talk on prefab, precast, and composite construction, vast scope, and its advantages. So let's welcome Mr. Prasad.
Let us start with, I am trying to cover the topics such as prefab and how prefab is automatically linked to precast, another technology coming. But both of them are mixing with composite construction. We are taking into precast, we're also taking the steel elements also as the beams and then providing color core slab on top of that, okay, and then using it. So I'm trying to tell the mix of it, how the technologies are mixing and how prefab is going forward with all the steel construction and all. Right. That's what is I hope I'm audible very clearly. So we have this construction material, steel, cement, sand, timber, PVC material, bricks, and all that. After that, today we are talking more about the steel as a material. It's a very versatile material in construction, and also in the PL, the steel is much used in the industrial sector of a pre-engineered building. Whenever you say prefab, people will think of steel first, because prefab as a definition in NPC 2016, they said that yes, prefab can be with the steel, can be with the concrete, can be with the timber or any material. But however, as the steel has taken an advancement in terms of constructing of industrial structures, predominantly with steel, prefab means people will think in terms of only steel. Thereafter, precast means now how to tell separately, yes, it is concrete material, right? So that is how our minds are already preoccupied. Yeah. So she has done beautiful cover so many curvilinear structures. Okay. Hats off to her imagination, and so many structures have come up in the entire Europe with her architecture. All these are done predominantly with the steel structures. Okay, even though there is partly some steel is there, some composite construction is there. But all these kind of curvatures and all abroad are done with structural steel as a mainstay, because structural steel is quite easy to do in the Europe, where the labor component is high with RCC, and then they went predominantly with steel. Even though steel is a mainstay of construction abroad, okay, compared to India. Yes, there are some Western structures again in steel. Some of these Millennium Tower, you can see this here. This is the concrete core, and then you can see there's a concrete slab. All these are steel columns filled with the concrete as a composite construction. We can also see that yes, steel columns and steel beams are again encased with reinforcement and filled with concrete. We'll be talking more about why it has to be encased, okay, and understand what it is. Yes, steel structures very high strength, about 10 times of concrete, predictable material properties, so the continuous one property, rapid and high quality construction, ductile and robust, good protection, can be easily repaired and refurbished, can be easily dismantled and sold as scrap, durable long service life, sustainability, adaptation of the application, and higher reliability and safety. Having said that, there are certain disadvantages also, susceptible to corrosion, high upfront cost, requires highly skilled people to eradicate, higher maintenance costs, low fire resistance, susceptible to static, susceptible to brittle patch. Even though the advantages are there, but still we are using this material where it is fantastically to be used and creating large column free spaces, such as in industrial structures. Okay. Now you can also see that there are certain space frames. They are possible with a steel structure with a very large column free spaces, especially in airports and stadiums. You all see that the large column free spaces is all possible with only steel. Airports are again with the steel with the large column free spaces. Railway stations are with the steel structure. All these are possible because of a large span to depth as a span to weight ratio is 0.5, and industrial buildings, large column free spaces and all are built with steel. So that's why I call this material as a very versatile material. High-rise building abroad predominantly uses steel. So we go into the pre-engineered buildings, okay, and for the industrial structures, we just take it up more right. So this is again the tailor-made building based on client's requirement. Okay, and then we can in between we can have some columns and we need not have columns depending upon the span. Okay, design and casting is done on the factory, and they come onto that site and then fixed and jointed at the site. All connections are predominantly bolted. We don't predominantly do any welding at the site predominantly, unless rarely it is required to. Now, what is a brief history? Steel is very expensive item, as we all know. But the concept of PEB, pre-engineered building, originated from here. That is the site. Steel is very expensive. A section should be provided as per the building moment diagram, right? If you are providing a section as per the building moment diagram, then it is steel. The PEB concept is coming into that. So it is strictly following the building moment diagram. Wherever building moment is high, at that portion, the section depth is more. And in other locations, the section depth is lesser. So in the pre-engineered element, these sections are tailored to meet that particular demand and fabricated according to that. So that's how we have done that. And the applications, yes, industrial buildings, warehouses, commercial complexes, showrooms, offices, schools, indoor stadiums, outdoor stadiums with canopies, gas stations, metro stations, bus terminals, parking lots, primary health center, underbodies, whatnot, so many things into that. So all these things are possible because it would be faster construction, okay, and it is prefabricated at the factory, comes and assembled at the site. So we have industrial buildings, indoor stadiums, parking lots, okay, like this various structures can be seen. So advantage, aesthetic appeal, faster completion, economical, okay, seismic resistance is good, ease of expansion. If the structure is built, yes, we can expand it by connecting it to the structure again. Maintenance free, predominantly logic clear spans, controlled quality, and hassle free. Now, if you look at the pre-engineered buildings and versus conventional steel building, two things here: pre-engineered steel buildings versus conventional steel building. So, in the pre-engineered buildings, self-weight is less, self-weight is more in the conventional buildings, 30% lighter and more heavy. Primary member is tapered section, whereas primary members of off-road section, which are readily manufactured and readily available. That is what conventional steel is. There we are wasting a lot of material. Whereas in the pre-engineered building, we are saving the material. Secondary members are lightweight roll frame jet and C sections. Yeah, they are called light gauge sections. Jet section as a purlin is a wonderful innovation in the steel sector, where the purlins are carrying to about 6 to 8 meters long, and then we are connecting them with some sag rods, okay, such that they will prevent the lateral buckling, okay, but at the same time carrying the gravity load. There's a wonderful material which are there. In a conventional steel building, you are going with a channel section or sometimes with I section, which is heavy. So that's where pre-engineered buildings takes an advantage. And delivery is 6 to 8 weeks. Where delivery in the conventional steel building is buying the off-road steel sections and all that will take time. Foundation is simple design, easy to construct and lightweight, whereas expensive, heavy foundation because the weights of conventional material is here. Erection cost in time accurately know, okay, and erection process is easy in the case of a PEB, whereas being a heavy material, it takes a longer time to put to that. Seismic resistance is again low because weight and flexible frames, lighter the weight, the seismic load attraction is lesser because of the lesser weight, whereas it is more in the case of a conventional construction. So overall pricing in the PEB profits are lower. Architecture achieved at low cost is something that we have to look at. Main primary members, columns, rabinets. Secondary members are purlins and girls, sheeting, roof, wall, fascias, etc. Accessories are ventilators, skylights, and miscellaneous. We have these various prints, column pre-structured one side, whereas a pitched roof, but where you have one the longer thing, multi-spans are there, 2-span, 3-span, 4-span like that. Okay, and then single slope or cellar span like this. And then we have roof and wall cladding system with insulated roofing. If you want insulated roofing, yes, there is a polystyrene or a rock wool is provided beneath the galvanized roof sheeting and attach it to that. Sometimes double skin is provided at the bottom also, or an aluminum foil is coming as a sheeting at the bottom of the insulation. So the advantages, we have this roof on one cladding system with a ventilation system also, and the steel material can be bent into curved to any shape with the cell, and the various structures are there in the PEB. That's how these elements can be made to. Yeah, you can see that some of the even lighting system can come into this with a polycarbonate sheets provided on the roof top, whereby they automatically throw the light inside, right? Along with that. Then optimization in the PEB design, which is one of the topics of ours. Here, the optimization that we can do is base spacing depends on the wind speed. Normally 6 meters we provide, and the maximum is 8 meters. Okay, and the pinged base plate at footing of stand is economical. So we try to provide the extent possible the period footing, and that will be taken care of in the design. And the roof slope of 1 in 10 is economical, and the rod bracing is effective and economical. Rod bracing, because the ends will be usually providing the bracing points, and as well as in the middle also. So these bracing, they are provided against the appeal to forces. These are provided for every fourth bay. There is an optimization that we can do and effective enough to be structurally stable. This economical design and the structure exactly resembles the BMB. For the multiple spans, yes, you can provide the columns at every 20 to 25 meters for the multiple spans. So that is about PEB design. But we'll move on to composite construction. In the composite construction, yes, we have the composite girder, an I-beam with an in-situ slab or a precast slab. In the composite columns, I can keep a column inside and then wrap it up with a RCC column there, okay? Or else I can keep my column and then within the flanges, I can pour concrete by providing the steel reinforcement. That is one way. Or I can take a square tube and then fill it up with reinforcement and pour concrete, okay? Thereby, I can achieve the strength parameters also, either 50% with concrete or 50% with steel or 30% concrete or 70% steel, whatever the way we want, we can do that particular thing. Similarly, composite slab also can be taken care of with that. Similarly, beams also can be encased in concrete again, okay? Or the box sections can also be filled with the concrete, okay? And thereby, what is the real purpose of providing this particular one? Is that the basic thing is the steel will be protected from the corrosion and as well as it gives a fire resistance, right? So that is a purpose for which we do the steel encasement, which is required in the case of a multi-storied buildings where the slabs will come, right? But however, it will have the shear characters, double shear character, which will give the composite action between the concrete and the steel beam, such that they act together, right? And then we can also see that, yes, there is a steel beam with the shear studs. There are the various pictures of that particular one. Yeah, steel beam with the slabs and how the connectivity can be done. Concrete can be placed in such that it gives. And this is a very famous one in the composite slab with a deck slab, profile steel decking, which will be placed on top of the steel beam. And the shear studs are punched through and welded onto the top flange of the beam such that it gives a composite action. And on top of that, they provide about 80 to 100 mm thick concrete with a reinforcement, which will be like a composite action we'll be developing. And it gives also the diaphragm action to that particular thing. This is the composite beam with the shear connectors, and it can be with the decking sheet or without decking sheet. You can put shuttering and pour concrete. Okay, so basically, you can see that the concrete can be encased in, the steel column can be encased in concrete, which will give the corrosion resistance and the fire resistance, which is much needed for the steel columns as well. And then you can provide a shuttering and pour concrete, or you can provide a deck slab as I showed you. Basic thing with this is that if you don't provide that, then you have to provide the fire resisting steel. Okay, two types of systems of that. One is a non-reacting insulated coating, and the other is a reactive coating. In the case of a non-reactive insulation coating, vermiculite and perlite are natural insulation material mixed with cement or gypsum for bonding capability with the steel surface and categorized as a foreign. And when you apply on top of the steel beam that will take a thickness of about 40 mm. And that looks a bit ugly when you apply it on top of that. Then naturally you have to provide some sort of a false ceiling, but the fire resistance is taken care of by providing with the vermicellate system, okay, on top of the steel beams, which will give the fire resistance, okay, into that particular thing. Reactive coating is such that when we're providing the intercell coating, okay, this will be, and sometimes the intercell coating is such that the cost of intercell coating is equivalent to the parent material cost. Okay, fine, it gives you about 2 to 4 hours fire resistance, but after applying this particular thing on top of the steel beam, it hardly takes about 1 or 2 mm on top of that, depending upon 2 hours or 5 or 4 hours fire resistance that we are looking at, which is our requirement for the fire resistance for particular thing. But after providing this, it looks so nice, being 1 to 2 mm instead of a 40 mm of fire vermicellate that you are applying on the top. Then there is no need of a fire false ceiling to this particular material. So this is how it looks like into center paint. Okay, basically it's a primer. Okay, then the pipe protection coating, which is also a primer plus pipe protective coating plus this is the top coat. Okay, the primer, and then you have a pipe protection coating, and then you have a top coat which will give you overall 1 to 2 mm, depending upon 2 to 4 mm fire resistance that you're. So that means if it is unprotected, after reaching about from 300 degrees centigrade onwards, it will start the bending. Okay, it will start melting, and upon reaching 550 to 650 degrees centigrade, it will start losing its strength and it will be bending more. Okay, so in the case of intermittent paint, it will react and form a charring effect, and it will increase in the volume of this particular paint, and it will give protection to the steel element. Okay, then by the fire will not affect the particular steel element. Okay, that is how this fire resistant paint, but is a must and should. We have to provide this if we are providing the steel beams and all that. But where you have a deck sheet, on top of that concrete is there, you need not apply the pipe paint to that. Now you can see here, we have done to the beams and the column, but not to the deck sheet. Why? Because on top of the deck sheet, you have already concrete is there. Concrete and that together will give you the fire resistance required for that particular thing into that. Of course, you can also use improvement fire resistance board, which gives again 2 to 4 hours fire resistance. These boards are usually coming from New Zealand, manufactured from there. They're also quite expensive, like into paint. Vermicellate is only the cost-effective material, but then you have to provide the false ceiling required for that. So this is something which you look at vermicellate when you apply to this process of how it will look like this. Okay, then we have to provide some sort of a false ceiling. This so that the person will be applied on top of that, which will be taking about 40 mm thickness to that. Of course, we also have the materials, okay, and in this type of this thing, we have built one of the buildings, a 3-story building in about 6 months' time for a nursing school in the Numali area, northeast region. But here we have used outside the cladding panels, which will have rock wool inside. It has a GA sheet, galvanum sheet, and both inside and outside, it has a rock wool insulation, which will give the fire resistance required for that. It is a drywall panel again, drywall panel. Okay? But of course, in the area of the toilets, we did provide brick masonry such that it will take care of the tiles and all that it can climb on that. For the rest of the areas, it is a rock wool panel, insulated panel, which will take care of the fire also. Rock wool has 2 hours fire resistance. Correspond to that, we have provided the thickness. Right. So the composite construction, it is of 2 materials. Concrete is efficient in conversion, steel in tension is well known. Concrete encasement resistance steel against the buckling. Concrete provides protection against corrosion and fire. Steel brings ductility into the structure. So as a casting slab without shuttering, this is what I was talking about, the slab. There is no need of shuttering. This will automatically provide as a permanent composite material, as well as it combines with concrete and acts as one element into that. So you can also say that it refers to any web composite of more than one material. Composite construction means, okay, these are rigidly connected such that no relative movement can occur. steel concrete composite beam, composite slab, composite column. Okay, functionality, pipe protection by using principles of reinforced concrete in which concrete protects the steel. Okay, and yeah, now what happens here is this carrying capacity and stiffness of the beam increases by factors of up to 2 and 3.5 respectively when we go for composite construction. Okay, it is not going to designed to be improper during construction, right? And that's the beauty of this particular. So composite construction, concrete filled tube, is nowadays much of this construction is also taking place. You can use a steel tube and then fill it with concrete. And if you want something more to increase it, enhance its term, you can also provide steel rods into that, okay, and as well as the links also, or you can provide some more steel form, because sometimes the architects will look at, I want a slimmer car. Then I provide one more steel element inside, one more steel element inside, and fix a fourth concrete. I have one outside element, and as well as I provide one more steel element inside, such that it takes care of my lateral resistance, forces, as well as the gravity moves, which will come into that. But here is an element. We provided the shear cuts inside and then simply filled with concrete. Okay, we have provided steel rods inside filled with concrete. Various ways in which you can provide the concrete filled tubes into that. Okay, this is how you can also see that the steel elements are provided, and then we provide shuttering and pour concrete into that particular element into that. And so it is basically protection from fire. So it's the composite beams, which we have already seen some of the details, and is a deck sheet on top of that, the concrete. These are the shear cuts, which will go into the concrete to give the composite action in there. Some of those pictures, steel beams, composite slabs, the deck slab, and steel beam. Okay, they're the composite slabs again. And we do not need formwork. Lightweight concrete is used, resulting in rigid deadweight. Decking distributes shrinkage time that prevents serious cracking. It also stabilizes the beam against lateral buckling and with the concrete or decks. Common types of floor systems are concrete slabs supported by open web joists. One-way and two-way reinforced concrete slabs supported on steel beams is possible. Concrete slab and steel beam composite floors, composite profile decking floors, recast concrete floors on steel beam. This is something that I will take you show the details in the when we come to the precast construction. Now, precast construction. This is also coming on par with the prefab construction. This is also called as a prefab construction. Prefab means and have multiple elements which are connected and then joined together to make as a rigid construction. Right? So we will slowly go through the precast, and then how I'm taking the steel also into my concrete will be seen into that. Right? Buildings from Middle East in the Prasad elements are precast with concrete. Okay, multiple, all buildings are going with precast construction. In the precast, one of the beauties is that we are creating hollow core slabs, solid precast slab, prestressed precast slabs, double piece, single piece like this. Hollow core slab can span up to 15 meters. Single piece slab can go up to 18 to 20 meters. Double piece slabs can go up to about 25 meters, even beyond 30 meters. Okay, by the beams are also can be precast. Okay, and the beauty is that in precast, the 3-story, 5-story precast columns are coming out and then joined. Then they are joined together, and then the beams will come and join at each floor. Thus, they are saving time into that. So precast hollow core slab is like this. They'll be with the help of clamps, they will lift and place it on the sisters. All these broad bars are pre-tested wires with the help of this particular precast hollow core slab. On top of joining them, we'll be providing about 60 to 70 mm structural topping, such that it creates the diaphragm action. This is how the industry looks like with precast slab. At the time, they charge about 120 to 150 meter long. Okay, and then the precast slab can be done. Yes, you can see that on top of the steel beam also, precast slab can be provided, and then on the precast walls, they can be provided. Beams also, they can be provided. This is how steel beam with the shear studs, hollow core slab coming along on both the sides, and then the reinforcement passing through, and then it creates a composite action. My philosophy of showing precast is that steel beams can be used as a floor beam onto the precast walls or precast columns, and then hollow core slab can be provided, thus it is becoming a composite slab. So double B slabs, as I'm telling you, okay, it can span across. There is a 10-meter column, free spacing, but then a double B slab is can span across 30 meter. When it is used in car parkings or in the shopping mall, is a large column free space. That's a beauty for the shopping guy, where thereby he can place his material wherever he wants. Okay, this is how the precast buildings are coming up in India. Okay, number of buildings are coming up because of that, yes, the school can be built in 28 days, they built it. And then, yeah, some of these precast buildings are also such that you need not paint outside. You leave it gray open like that. One architect has done it in such a way that the railing only is made with a color, but outside it is gray. Inside only gets done to the walls for ambience purpose, the painting. Okay, again, to the precast slab, we have done the painting. Okay, yes, the 16-story precast buildings are built here in Ghaziabad, NCR region. Some of the beautiful things can be done in precast also. Okay, and one precast India infrastructure have done this structure with a concave and a convex facade elements, which will bring light into the structure. They saw the building is bent. Okay, some of the precast structures, right? And yes, there are 2-story, 3-story into that. And then the point that I'm trying to bring is precast is also coming into industry, whereby they are making the precast columns also. However, they are using the wrappers also with precast beams. Okay, but then the roof, still we are going with the jet burnings and the roofing sheets, such that precast and the composite construction is happening into this particular thing. Prasad, once again, the precast elements are coming up. This is how the buildings are built into, right? So this is how the precast is coming up. And then we are mixing both the roofing element as well as precast element into that particular thing, okay, which is coming up. Then the data beams, which can be have precast slabs coming up into that, okay, it's like not normally beams, okay, the concrete will flow into that, okay, there is a special beam made for that particular color, right? So with that, I will close my presentation. Thank you very much.
Thank you, Mr. Prasad, for your talk on prefab, precast, and composite construction, vast scope, and its advantages.